Okay, so we're back into this R introduction. So this is nearly everything you might need to know about R part 2. So I can't tell you everything you need to know about R, but hopefully this is enough to get you started. Like I said, there's a lot of information about R, about how to use R. Think about what you want to do and then try to find an example that does that. Here are some resources that I've pulled from for some of these lectures. They might benefit you as well, but still, break it down. What do you want to do? And then step by step, find an example of how to do that, either from my scripts or from examples people have published online. There's a lot of cheat sheets. So cheat sheets for specific packages or specific commands or groups of commands. Here's a link to them. There's a lot of information. And again, it might be the exact example that you are trying to accomplish. Someone else has put together in one of these cheat sheets. So some things that we're going to introduce today, talk about some of the descriptive statistics that are built into R that we can use to investigate our data. Understand the format of what I'm calling logic and loops. So these are if statements, for statements, anything to make our lives coding this code easier, these kind of loops. And then we're going to end up with talking about ways to make plots that provide information to our readers. Okay, starting out with simple statistics. There are a lot of stats that are built into the base level R, meaning that you don't have to install a package to get an average value or the minimum or maximum. As long as you know the command, you can get the statistics out of it. This includes minimum, maximum, mean, median, mode, percentiles, standard deviation. These are all different summary statistics, ways to describe your data set. So min, max, pretty easy. You tell it your numerical vector. This could be, in this case, it's a vector, but it could be your table $ column. You're referring to one column in your data table. And here we have an additional command. This is NA, so any value that is classified as a missing value, you have to do that ahead of time if it's not just NA. We're telling it NA dot remove equals true. So it could be that some patients in our table, they didn't have a recorded age. So it's just NA. And if you try to do some sort of math on a column with NAs, R does not know to just ignore those NAs. You have to tell R, ignore those NAs because you can't do math with NAs in our vector. So that is something we have to tell R to do. It's a good practice to just include that in there, whether you have NAs or not. Also, there is mean for average. You add up all the values, you divide by the number of values. Median is the middle value. So you rank all of your values from smallest to largest, and you find the middle. This is useful if you have a data set that you want to divide into 2 equal data sets. You find the median and you split them. Mode is the most common value. I don't use this a lot, but you count the instances of all your values and you sort them by the count. The one with the most count is your mode. Percentiles. Sometimes we talk about percentiles within these data sets. We do it a lot with kids and their weight and height. So percentiles, it describes the value that would be the cutoff for a particular percentage. So 50 percentile would cut our data set in half. There's quantile. quintiles, which are those quarters. So it's 0, 25, 50, 75, and 100. Those are specifically the quantiles. Or you can just specify a percentage. So percentiles, they're anything from 0 to 100. Quartiles specifically divide into 4. Quantiles. Quantiles are those 25%. Might have that flipped. And percentiles and quartiles are both types of quantiles. It's very confusing, but the most important here, this is a nice summary. If you divide into 4, it's quartiles. You divide into 5, it's quintiles. 8 is octiles. 10 is deciles. They're like decades. And 100 is percentiles. We use this a lot when we're making a box plot. So there's our range of data, it was 0 to 100, and then we will have our box, which is, we talk about it right here. It's the box is the first quantile to the third quantile. And we also call that the interquartile range. So you might see that sometimes. But that's that box of your box plot. And then the line of your box plot is the median. I'm going to show box plot later when we talk about plots, and we'll go over that again. And then just one more statistics that R can calculate for us is the standard deviation. This can tell us our values, are they far away from the average, or are they sort of typical, spanning around the average? So we can use a standard deviation to maybe classify outliers. If they're more than 3 standard deviations away, those could be outliers. So we can calculate that using this SD function, or we can do it by hand with the square root of the mean of the values minus the mean of the values to the square. So you got to get all those parentheses right. They give basically the same answer, but there's some differences in handling decimal points throughout all of these processes, and so they're going to be very slightly different. It's a good practice to just use SD because it's built in and it handles all of those decimal places. Okay. So that was all about the basic statistics in R. You can also look up the functions for, it's called which min and which max. And this is going to pull out the value which has the biggest or the smallest value for that column. That's sometimes useful. Okay, so now we're moving on to our second topic, which is what I'm calling flow control. It's ways of controlling the flow of your scripts. And these are the logic statements of if and for and else, and there's while. Sometimes I don't like using while, but it's mainly if statements and for loops. Those are what we're going to talk about. If you've done any kind of programming in the past, you've seen these concepts. So okay, so we're going to start out with if statements. If defines a block of code that will be run if the logic is true. So we have some really simple if statements here. We assign the score to be 90. You can assign it whatever you want. So we've assigned a value to score. And then in our if statement, we have the word if, it's all lowercase. And in the parentheses, we have our logic question. And we ask, if score is greater than or equal to 50, we're going to do some code. And in this case, the code is just to print you won to the screen. So if asks, is this logic statement true? And if it's true, we're going to do something. It can be more complicated than that. So in our second if statement, we have 2 values. And we're asking if score is greater than or equal to limit, then we're going to do the thing. And then in our third example, we have two different logic statements divided by an or. Or is that up and down line. So if score A is greater than or equal to our limit, or if score B is greater than or equal to our limit, if either one of those bring back true, then we're going to print U1. So this is or, and is that and symbol. And so and would require both parts of the logic statement to be true. Or means either one, where and is both. So remember that if you're doing any if statements. We ask for a logic statement in the parentheses. And if that logic statement brings back true, we do the thing. And as you're coding, if you just highlight score greater than or equal to 50, you can run just that part and it will return true or false. And that's how you can kind of guess, is this if statement going to run or not? I mean, in this simple example, we know. But if you get a complicated thing, I don't know in this run through whether it's going to run, and I don't want to run it if something's going to be messed up. So we could highlight just the logic statement and ask in this run through, what's the answer? So think about that as you're debugging your code. Okay, so we have an if statement, and it just does the thing if the if statement is true. We have our code in curly brackets after the if statement. Then after we close our curly brackets, we can have an else statement. An else is kind of a catch. If our if statement is false, then we want to do something else. And that's what we have in our else. We have else, that we have more curly brackets. If our if statement was false, we're going to do something else. So this is what's going to print if it's false. We can get extra fancy, and we have an if, else, if. So first we start out with our if. We have if this is true, we're going to do what's in the curly brackets. We're going to print U1. If it's false, we're going to go to this else, and we see, oh, there's another if. So our first if was false, so we're going to skip this. We're going to go to our else. We're going to check something else. But we can't immediately just do the else because there's another if. We hit an if and we ask, is what inside the if true? Then we're going to print this. So that's an if, else if. And you could have another else after this. It could be your catch. If the first thing is false, if the second if is false, we're going to have a third else. That's just our third catch anything else right here at the end. So think about how the logic's going to flow through your if statements, your else statements, your if, else, if statements. Think about it, how it flows. So that was ifs. The other option are loops. And where if is done for a yes or no situation, loops are made to perform repetitive tasks. We're going to loop through all of these options, or we're going to keep going until we hit our limit. And R will execute the block of code for as long as the logic is true. You can do this for a set number of times or until the argument's true. There's 3 types of loops. I'm only going to talk about the first one. We have for loops, while loops, and repeat loops. Whiles and repeats, they're a little dangerous because you could get stuck in an infinite loop. For loops, you define how many times is this loop gonna run. Defines a block of code to be run a specified number of times. Repeats for a known number of times. Usually iterating over a sequence. So in our first for loop, in the parentheses, we define our value and then what that value needs to iterate over. Here we're saying from 1 to 10, print I. And the second one, we have val as our value. And we're saying for every val in this character vector, we're going to print val. So it's going to print for 1, it's going to print 2, it's going to print 3 as words. It's doing each one of these. You could save your vector as a value. We're assigning this vector to be X. And then we're saying for val in every value of X, print val. So for loops have a set number of times. While loops are going to keep running until your logic statement goes from true to false. Let's go stop. So I use for loops all the time. I don't think I've ever really used a while loop in an R script, but look into them if you think it's going to be useful in your programming life. Okay, so we've done simple stats. We've done logic statements. Now we're going to talk about visualization. And there's 2 ways to do visualization in R. Main ways. There's the base R. So you don't have to install anything. It's just what R has by default. It's easy and it's quick, but it's not very pretty. The other option is ggplots 2. It's a package. It's part of the tidyverse. It's something that you're going to be installing as part of your list of packages. And it's very customizable. It's very modular. You set up your base plot, you can add things to it. So my nose is itchy. It's very useful. There is a website online. It's the R Graph Gallery. I can't go to it right now, but it's a website. It has all of these different chart types. You can go there. You can click on your chart type that you're wanting to plot. It's going to give you examples of how to generate this plot in base R and how to generate this plot in ggplots 2, how to get the shading different ways. Maybe you want to split it by groups. It's going to have all of these options, and it's going to tell you the script, the commands to plot each one of these options and versions. It's just an amazing resource. So if you want to plot a graph and the scripts I give you are not enough, go to this gallery, and I guarantee that your chart is going to be here with a pretty close example to what you want to get. Okay, so there's base R, nothing to install, very basic. There's ggplots 2, it's part of the tidyverse. You can install it from CRAN using the install.packages command. Make sure your package is in quotes when you're installing it. Okay. ggplots, it's very nice because it starts out with a ggplot function where you tell it your table, and then in the aesthetics function, you tell it the variables, the columns from your table that you want to plot. You tell it your X variable and you tell it your Y variable, just the column name. Whether you need both an X and a Y depends on the plot, and we have examples for all the different types of major plots in ggplots, and with listing what each one needs to be. So ggplot, the main function, it's going to initiate your plot. All it needs is the table and the aesthetics specifying X and Y column. These are all the different plot types I'm going to talk about. There's histogram density plots. They're very similar. Histogram has bins where density plots does not. Scatter plots, just points representing an X and Y axis. Bar plots is usually just one measure separated by groups. Box plots, I think, is the most useful way of visualizing data. It's where you have your range of data and those percentiles. Similar to box plot is a violin plot. It's gotten more popular since single cell has come onto the stage. So we'll talk about that too. Okay, I've already introduced ggplots2 with their layers. You initialize your plot with ggplot. You can save that. So we assign this initialized plot to G. It's not going to plot anything if we just plot G because it doesn't know what to plot. We're just saying, use this table, use these columns. And after you establish your base function, your ggplot function, you can add layers. You tell it, I want to make a geom point. So this is a dot plot. I want to make it a dot plot. I want my color to be this vector. I want my shape to be this vector. I want to add on labels to my plot. My main plot title is plot. My x-axis label is x-axis. My y-axis label is y-axis. Then I want to add on some more, or I want to add on the theme, which is this, where the size of my text is 25. Now, as you're adding to your ggplots plot, you literally use the addition symbol, but make sure that if you're making a new line, you have your addition symbol and then make a new line, because then R knows to keep going. If you make a new line and your addition symbol is on the next line, R doesn't know that they went together. R has color palettes. Some of them are built in, some of them are saved in packages. So you can look at either one. This package I reference here, it will tell you the base level R colors. So if you want to know what is the particular code for the color that R is using in your plots, because maybe you want to use it somewhere else, check out the scales package and it will tell you that salmon that they use is such and such value. An alternative is the color palette schemes from Color Brewer, and they have a very nice website you can play around with. You can tell it, these are the number of groups I have. I want my data is either sequential, where it starts out small and it gets really big, or it's diverging, where we have just independent groups, or it's qualitative. Diverging might be two extremes with your center in 0. I don't know. Check it out. And then qualitative is just random groups. So don't quote me on that, but I think that's what it is. And then you can further filter on what particular color combinations you might like. You can filter on whether this is good for publication, print friendly. Is it good for photocopies? Is it good for people who are colorblind, who might not be able to distinguish red from blue? So think about what colors you might want to use, and you can load these color palettes through R, or you can just copy these these color names, however you want to do it. Just know there are resources out there for colors in R. There's also different shape options. Shapes are customizable. You have to specify a number. And you can look, so here's the examples of what the numbers mean for line types, shape types. I don't think I have that printed here, but I have it in the code. And so check that out if you want to see what the number that corresponds to a black dot means versus a triangle, black triangle. There's different numbers for each shape. Just like there's different numbers for each type of line. You can also control the size of your shape. Okay, So now we're going to get into plot types. Histogram has bins. So this is, can I hide? There we go. Okay. So in a histogram, you divide your data into bins, and in the commands for your plot, you either control how wide the bin is or how many bins there are. So the width of the bin is bin size. The number of bins is just bin. And you specify one, and R knows how to divide up your data. You only specify one value, so your X axis. You don't have any group comparisons really here. For that, you would use a bar chart or a box plot. A histogram and a density plot, they represent the distribution of your data. If you want to make a histogram, base level R, the function is hist. You tell it your table $ column, or it could just be a vector of numbers. In ggplots, you're going to tell it your table. You're going to tell it one variable, so our X value. And we're going to add on that it's a histogram. This will plot a histogram. You can also play around with some of these options of bin size, bin, number of bins, colors, whatever. That can be added on too. A density plot is a histogram with no bins. So it looks smooth. Oh, I don't even show. Damn it. Okay, so density plot, I think it's just density for base level R. And then for ggplots, it's geom_density, probably. Yeah, it's right here. Okay. Density. You can control the color just like a histogram. Okay, here's a scatter plot. It's going to be the relationship between two numerical vectors. You have your x-axis and you have your y-axis. So it's not surprising in our ggplots, we need to specify x and y. And then we add on geom_point to get a scatter plot. If you're just using base level R, the function is plot, and you tell it your column for your X, comma, your column for your Y. Here I'm referring to them just by the numbers. You could also do table $, the column name. But you have to make it a vector somehow. Okay, this is a bar plot. It's a relationship between our numbers on the y-axis and some character groups on the x-axis. And it's going to show, maybe it's a count for each group. If this is an average, maybe you could include error bars, but if you're going to do that, might as well do a box plot. For base level R, the function is bar plot. You can tell it your heights, so this would be your value. You can tell it your groupings as names. For ggplots 2, we give it our X grouping and our Y value. These would be column names. And then we add on geom_bar. And since in this example, we're just plotting the value that's already there. The stat equals identity. If you need R to do the counting, then that's a different option here. And I'll show that in the code later. Okay, so we've done histograms, scatter plots, and bar plots. So now we're going to look at box plots. And a box plot will show the relationship between measurements across groups and also give you an idea of the quantiles in each one of those groups. So We have the minimum and the maximum. We have down here, we have the 25%, we have the 50%, and we have the 75%. Gives you an idea of the distribution of the weights of these cats. We have some very large cats. You can also, so this is a box plot version, you can also have violin plots, which would actually have density plots on either side rather than just box. So that's an option. This is explaining what a box plot is showing. It does a little bit of calculation to decide whether the minimum and maximum values should be outliers or whether they should be included in the minimum and maximum. And then our box is an interquartile range. So if you were curious about what a box plot actually means, this explains it pretty well. Okay, if we're going to make a box plot, base level R, there's a box plot function. You tell it your measure, a twiddle, and then your grouping. So this is sort of a formula notation. You tell it the values, and then you need to give it the twiddle, and you tell it the groups. For a ggplots2, we set it up with our ggplot function, telling it the table, telling it our groupings for X and our measure for Y, and then we just add on box plot. It's as simple as that. Now, you've done some visualization on your data for your publication, maybe. You have a density plot, you have a box plot, and you have a bar plot. And you want to put all three of those into your figure 1. There's some ways of doing that in R. If you're just using base R, you can combine them into panels of one larger figure with this par function. If you're using ggplots, look into some of these other packages for grouping ggplots together, such as the ggarrange function from the ggpubr package. And this will provide nice ways of putting together your plots into one actual figure. Let's see. Okay, so we've made plots. We have ways of combining the plots into one figure, but you need to get these plots out of R. Think about what file format you want to use. Do you want to spit these plots out to PDFs? Do you want maybe a JPEG, a PNG, something that's lossless, something that's high quality, like a TIFF or an SVG? Those would be single plots. So whenever I want to just spit plots out, a whole bunch of them into one file, I'll put them into a PDF. If I want high quality plots for publication, I'll put them into TIFF or SVG, something where I can control the resolution and get one really big, nice plot. So as we're exporting these plots, we have a command that opens a file. If we're going to do a PDF, the function is PDF, and in parentheses, we specify the file in quotes. You can control the height and the width of that file. There's some other options. You can check those out in the help panel. So you have to open your file, open your PDF, do your plots, and then run this command called dev.off parentheses, and that will close your file. If you don't close your file, if maybe you open another file and try to run some figures out to it, everything will get malformed, and you have to run dev.off a couple of times just to close everything, and then you can rerun your scripts. So always be sure, open your plot file, print some plots to it, close your plot file. Don't try to go back and do something else. Don't try to open any other files while you're doing that. Just open your file, print to your file, close your file. If you don't do that, it's not gonna work. Okay, so that's the end.